Hello and welcome to Let's Learn. So today is going to be something new. We'll be looking at the new KSSM Mathematics for Form 4. Now I will try to release these every Monday. It should be either Maths or at Maths. Right, so I'll try to release one of these every Monday. So try and check it out. And what I'm going to do is not to go through the entire thing, but I will give an overview, right, just a summary of what you need to learn in every chapter. Alright, so just for today, we'll be looking at chapter 1, where it's quadratic functions and equations in one variable. Alright, so for our quadratic function, we have the highest power is 2 and involves only one variable, which usually is x. Right, so you're going to have something like y equals to ax squared plus bx plus c, right? Or maybe fx is equals to ax squared plus bx plus c. Alright, so if you have x to the power of 3, 4, 5, then that is no longer a quadratic. If it's x to the power of 1, it's also not quadratic. Alright, your quadratic, you need x to the power of 2. Right, must be an x squared. Even if it's not x, it's something else. Let's say, I don't know, let's say a equals to, too used to using x, b squared plus 2b plus c. Right, as long as it's squared, right, a is in terms of b, then this is a quadratic equation. Okay, now for your quadratic functions, oops, sorry, it's a little bit too high up. Let me bring it down a little bit. Alright, so the shape of the graph will always be either a smiley face or a sad face, right? So it's either the mouth is smiling. Alright, this is when the a here is a positive. Right, so when a is larger than 0. Now, when that a is a negative, it will become a sad face. So where a is less than 0. Alright, if a equals 0, it's no longer a quadratic. Okay? Now, for these parts here, you can memorize it, where if b is less than 0, then your axis of symmetry is on the right hand side of the y-axis, or fx. Right? If b is more than 0, it's on the left hand side, or if b equals to 0, then it's right at the center. Right? Or you can look at this one when it is a sad face, right? That means when a is less than 0, when b is less than 0, the axis of symmetry, that means right when you cut the graph right at the center, right, into two equal halves, where you can just fold it over, right, it will be on the left side of fx, or your y-axis. But when b is larger than 0, then that axis of symmetry is on the right side of fx, so it's the total opposite. The only one that is the same is when b is equal to 0. Right? Now, for those of you that are saying, yeah, I know you're memorizing it, but why is it like that? That is a good question. Why is it like that? So when you have fx is equals to ax squared plus bx plus c. Alright? Now let's say it's equals to 0. No, I won't let it be equals to 0. Now, you have learned before on using what do you call that now? Factorization to find the values of x, like the roots of the equation. Now, there is one way called completing the square, where first I have to change your equation to x squared, where I divide it by a, plus b divided by a times x plus c divided by a. Alright, so completing the square would be where you have x squared plus b over a, you have to divide it by 2. So it's b over 2a, you square it, plus ca, and I have to minus out my b over a. Why is it? Because when I open up this bracket, I'll have x squared plus b over 2a times x plus b over 2a times x again, right? And plus, minus b over a squared. I forgot. Right, so plus b over, not b over a, but b over 2a squared. Alright, so that's why you must minus this thing out. Right, if you forget, in this case I kind of did, right, then this thing will make your equation wrong. It will not go back to ax squared plus bx plus c when you times in the a. Alright, now when you have this equation, when you have already completed the square, what you would learn would be, oh no, see, I make another careless mistake. So it should be only x on the inside of the bracket. Now, this here, we will be able to find the value of x on the axis of symmetry. So it's negative b over 2a. And this whole thing is actually the value of y on the axis of symmetry. Right, because where is the axis of symmetry? Oh, sorry, not... Yeah, it's still on the axis of symmetry, but these two values here, where y or fx is equal to c over a minus b over 2a squared, these are the coordinates of either our minimum or our maximum. Alright, so let's go back to this part, where if a is more than 0, if a is more than 0, right? Now, so if a is positive, this bottom part will be positive, right? And now it depends on b. If b is a positive, then the value of x here will be a negative, right? Because positive is positive, positive negative is negative. Right, now if b is a negative, this is a positive, right? That's a negative. So now it becomes negative, right? Negative and a negative, it becomes positive. Right? So, remember, if a is positive and your b is positive, then the value of x will be a negative, which is like this one. Then, when a is positive but b is a negative, right, then the value of x will be a positive, just like this one. Okay, now with this I can also use it for this graph, right? When a is less than 0, so a is negative now. When a is negative and b is negative, So negative is positive, positive with negative becomes a negative. So you can see it's on the left hand side of fx. Then when a is negative but b is positive, negative and positive is negative, right? And then negative and negative is positive. So remember all the time where you have to memorize what po 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 ne ne po. I heard that from the school nearby. It's hilarious, but yeah, you're applying that here. Okay, so remember these are the coordinates for either the maximum or the minimum. That means the highest point on the graph or the lowest point of the graph, right? So if you want to learn completing the square, there are many resources for you to find. You can just Google it. Okay, so that way, if you are the kind that can't remember any of this, you can try and use completing the square to help you. Alright, you will not be penalized if you use completing the square, because we are not supposed to be rewarded for just blindly memorizing things. We are supposed to be rewarded for knowing why is it like that, right? That's where critical thinking comes in. So instead of learning by rote, if you can, learn why, right? So I hope that explains a little bit. I kind of made myself a little bit confused earlier because I was pointing at the wrong ones. Alright, so general form for a quadratic equation will always be ax squared plus bx plus c. That's why even earlier, your y of your fx is always ax squared plus bx plus c. Okay? Now, roots of a quadratic equation are the values of the variable that satisfy the equation. So in this case, you can either use factorization, graphical. For maths, you will have completing the square as well as the formula method. Alright, so graphical method is the easiest, where you draw out your graph, and as long as they're touching the x-axis, those 2 points, those are your roots. Okay, and also if you're learning maths, you will know there are 2 distinct roots, one row root and no row roots. But if you're not, don't be bothered. Alright, now for factorization, basically with ax squared plus bx plus c equals 0, you want to have it into 2 brackets, right? Plus or minus. So this one, what you will be able to learn is that if I reverse it, okay, so let's say the roots are alpha and beta. Okay, so this is basically reversing how you do your factorization. So x equals to alpha, x equals to beta, right? Now when I bring them over, it becomes x minus alpha, x minus beta equals to 0. Right, so when you factorize, you're supposed to come with this, you're supposed to end up with this equals to 0, and that's where you find x equals to something and something, and these are your roots, right? So now I'm doing it in reverse. Now when I open up the brackets, it becomes x squared minus alpha x minus beta x plus alpha beta equals to 0. Alright, so in this case, the a is 1, so you have x squared plus negative alpha negative beta x plus alpha beta equals to 0. Or you can make it as x squared minus alpha plus beta x plus alpha beta equals to 0. And if I compare this, ax squared minus plus bx plus c equals to 0, because there is no number here, So whatever number that I have here, I divide by a to get x squared plus b divided by a times x plus c divided by a equals to 0 divided by a is 0. Alright, then when you compare them, okay, x squared, I have x squared. Good, they are the same now. Now our b divided by a is equals to negative alpha plus beta. Right, so if you're given the roots and they're asking you to form, your quadratic equation, this is a good way to do it. And then your c over a is equals to alpha times beta. So remember, your b over a is equals to negative alpha plus beta in brackets. Alright, and then your c over a is equals to alpha times beta. Okay, so this is the reverse of factorization with from here, right? You get to this one, they're the same anyway, right? You get to this one, get to this, this, and this, right? If you have done your exercises and you have take a look at it, you will see that if you look from bottom up of your exercise, it would be in the same how do I put it, with the same steps as what I've done from top to bottom, right? I have just reversed it. Okay, so I hope this would have helped you a little bit. Maybe you can understand a little bit more. And as I said, it's only a summary, so it's not going to be comprehensive because I have other things that I want to do and I don't really have a lot of time right now, right? Because anyway, now we are in CMCO, so I'm releasing this as soon as I can, right? But I'll try to do this every Monday, either maths or ed maths. So just remember to subscribe, hit the bell icon, right? I don't know, share it with your friends, alright? Maybe it'll help them, because I know a lot of you are finding maths is difficult, but it's actually not, right? Once you learn to understand it, you do a little bit of practice and you'll be doing just fine. Alright, I hope to see you in the next video. Bye!